Bergson and the Holographic Theory of Mind, Part 59. We'll be looking at Solms, Mark Solms, his new book, on feelings, or feelings, affect, and pain, which is really the other piece of the hard problem, which I really haven't discussed. And we'll be looking at Bergson's framework on this versus Solms. So the other piece of the hard problem. Why does it feel like something? That's the normal formulation of the hard problem. We're going to look at Solms and his proposed solution to the hard problem, which we will see is heavily focused on the source of affect, emotion, pain, feelings. But first, this to note. I've insisted on the more general statement of the hard problem as being this: accounting for the origin of the image of the external world. The external image is filled with dynamic forms, changing constantly over time, vibrating colors at a scale of time. In other words, filled with qualia, and the external image is certainly seen as something it is like. And we've seen this requires an incredibly brilliant solution. In Bergson's framework, a holographic field, the brain is a reconstructive wave, passing through this field specific to a source, right where it says it is in the external field. The brain's dynamics, chemical dynamics, specifying a scale of time, a buzzing fly or a heron-like fly, or a whole ensemble of electrons. So this was quite a breakthrough necessary for the origin of the image of the external world. This problem statement, the origin of the image of the external world, just jars the philosophers. No, I've had folks say the problem is this, the hard problem, explaining how it feels like something. Of course, this stems from Chalmers. To quote in his 1995 article, why is it that when our cognitive systems engage in visual or auditory information processing, we have visual or auditory experience? The quality of deep blue, the sensation of middle sea. How can we explain why there is something it is like to entertain a mental image or to explain an emotion? It goes on, why doesn't all this information processing go on in the dark quiet brain, free of any feel, any inner feel? So a solution to the origin of the image of the external world, this does not even register on the mind programming of the philosophers that is set in via this why it feels like something formulation. Yes, there is an affective component in viewing coffee. For example, I'm looking at the coffee and I say, yum, hot coffee, or oh, wow, do I need some coffee to wake up, or nothing like the aroma of coffee, or warm up those hands, my cold hands on that hot cup. Our perception is permeated with these feelings. Yes, these are a part of what it is like, but only within a framework that solves the origin of the external image does the nature of affect, pain, emotion, take its place. These are two parts, symmetric halves of the same problem, but they cannot be conflated. And this is a conflation we're going to witness a bit later in Solms. So we've got the feeling, yum, hot coffee, and we've got the very qualia-filled image of the external world, both combining for, we can say, what it is like, if you wish. Now, Bergson devotes all of 2 paragraphs, maybe 3, in Matter and Memory to the question of affect. In the summary conclusions, in section 4, the first 2 paragraphs. Why this little? Precisely, I think, because establishing the solution to the origin of the image of the external world and its implications for memory, that is, experiences not stored in the brain, is far more difficult and truly prior. And as just noted, affect then falls out naturally. But I should note, Time and Free Will, however, can be seen as a large discourse on affect. Again, noting that subtitle, the immediate data of consciousness. But we're going to neglect that in this particular video. So let's look at the Matter and Memory paragraphs. The first paragraph is to quote, but this theory of pure perception had to be both qualified and completed in regard to 2 points. For the so-called pure perception, which is like a fragment of reality, detached just as it is, would belong to a being unable to mingle with the perception of other bodies, that of his own body. That is to say, its affections, nor would it be able to mingle with its intuition of the actual moment, that of other moments, that is to say, its memory. The paragraph continues, but stop here for a second. Pure perception is the holographic field, taken at a single instant, not over a span of instants, a continuous, truly continuous span of instants. No, it is a single instant, the most minute instant or interval of time, what I call the null scale of time. And at this scale, the state of each point in this field, in this holographic field, reflects the states of all other points. Thus, there is an elementary form of awareness, very elementary, that is perception defined over this field at this null scale. I didn't note it here, but remember, Bergson said the problem is going to be how this perception is limited, not how it is generated by the brain. There is thus far no continuity, no flow, no memory, just a state of the field and another state, then another. So we have a being, but with no memory. To continue. In other words, we have to begin with, and for the convenience of study, treated the living body as a mathematical point in space, and conscious perception as a mathematical instant in time. That is, we are yet in the framework of the classic metaphysic. Space, the continuum of points, positions, and time, the fourth dimension of the space, the series of instants or instantaneous spaces, a four-dimensional structure of instantaneous three-dimensional spaces. And continuing, we then had to restore to the body its extensity and to perception its duration. By this, we restored to consciousness its two subjective elements, affectivity and memory. So, now we set the holographic field in motion, transforming indivisibly like a melody, with each moment, that is, note by analogy, reflecting the entire preceding series of notes, or moments, or instants. So, we have then a primary memory defined across the motion of the field, because it's an indivisible transformation. The past does not fall away into non-existence, instant after instant. It's an extended, continuous, indivisible flow. The body is extended, one with this field. There's no true spatial separation. And thus the body, too, we should note, has this primary memory intrinsically. So the body, as a reconstructive wave, then passing through this holographic field, is specific to a source in the field in the past. We can have it specific to a source in the past. For the indivisible transformation, in that indivisible transformation, there are no instants falling into non-existence. The past can be specified, as we said. This is now the framework of the temporal metaphysic as defined by Bergson. So why does he say affectivity was restored? Next paragraph. So what is an affection? Our perception, we said, indicates the possible action of our body on others. Again, he notes, any given object that acts upon all other objects in the field is in turn acted upon by all other objects. It is in fact obliged, quote, to transmit the whole of what it receives, to oppose every action with an equal and contrary reaction, to be, in short, merely the road by which pass in every direction the modifications of what can be termed real actions propagated throughout the immensity of the universe. In other words, like waves, every object acting upon every other object. But perception is virtual action. The brain is selecting a subset of the real actions in this field, that on which the body can act. We are seeing how it can act relative to a specified scale of time. So continuing, but our body, being extended, is capable of acting upon itself as well as upon other bodies. Into our perception, then, something of our body must enter, When we are dealing with external bodies, these are, by hypothesis, separated from ours by a space, greater or lesser, which measures the remoteness in time of their promise or menace. So distance also implies equals time here in this perception. The remoteness in time of their promise or menace. They're like time markers, which is why our perception of these bodies indicates only possible, and it's only virtual actions. But the more the distance diminishes between our bodies and our own, the more the possible action tends to transform itself in a real action, and the call for action becoming more urgent in the measure and proportion the distance diminishes. And when this distance is nil, that is to say, when the body to be perceived as our own body, it is a real and no longer a virtual action that our perception sketches out. So the body is integrally part of the sea of real actions. These are melodically, indivisibly transforming, not instant after instant, discrete instant after discrete instant. This is the basis of the body's affect. Such is precisely the nature of pain, an actual effort of the damaged part to set things to rights, an effort that is local, isolated, and condemned to failure in an organism that can no longer act except as a whole. Pain is therefore in the place where it is felt, as the object is at the place where it is perceived. Between the affection felt and the image perceived, there is this difference, that the affection is within our body, the image outside our body, external, internal. And that is why the surface of our body, the common limit of this and other bodies, is given to us in the form both of sensations and of an image. So this is Bergson's framework for affect. Let's place Solms within it. Well, we'll try. He's not going to fit. Solms' framework is that of predictive processing. He's an advocate of Carl Friston's approach to this. We viewed predictive processing in number 14 and its cousin, the higher order thought theory, in number 48. In general, the brain system is generating predictions, both of the external world and of its internal world, the affects. These are continually matched to the input received. The error discrepancy between the prediction and the input is checked, so we've got a prediction there. Input is actually suppressed, actively suppressed in favor of prediction. So for perception, if there is a match, you are literally only seeing the internal memory or predicted image. Else the projected memory image is adjusted in case there's error. Now this is kind of curious because when asked, does one see the coffee cup first, the predicted coffee cup? Then there's an adjustment for error. Then you see this coffee cup. The answer seems to be no. The error is adjusted, the internal error inside the brain, to form a new prediction, a memory image that is another projected image, a memory image. Thus, always such, always a memory image. This would be even for a completely new novel event, a coffee cup like the likes of which you've never seen. I just find this curious. Where did these memory images come from then? The brain's got to be creating them, generating. But there's no initial perceptual image to ever be stored. Well, one will search Solms in vain for an answer. So a heavily favored concept that Solms notes around the late 1800s was that the cortex in the brain is a seat of consciousness. Early theorists, Solms notes, insisted that the experience consisted of memory images produced by the cortex. It is important to recognize that the mind, in this view, consists entirely of memory images that reflect past experience of the outside world. But didn't we just see this? One wonders in this very thing in the predictive processing framework. Well, for Solms, consciousness is not just images from the cortex, as we'll soon see, but we'll see for him it certainly involves these memory images from the cortex too. That is, as far as I can see, only memory images coming somehow from the cortex. He goes on, incoming sensations merely stimulate these images and their associations into consciousness. So again, the implication. There's no actual perceptual image. It's just the stimulation of images in memory. Again, one wonders, how did they not ask where the memory images came from? How is the brain creating these? That's kind of the hard problem. But Solms actually states early in the book, starts early in the book with vignettes of hydroencephalic children. These are born with virtually no cortex, and yet, his observations show they are obviously conscious, have feelings, joy, they love what they're doing, can be very happy, and so the cortex cannot be entirely critical. He quotes, he says, when we look at our own consciousness, there are general categories of content. There are, of course, representations of the outside world, those internal representations, say of the hornet, both perceptions and memories of it and thoughts about it. Philosophers have heavily attended to these, but, to quote, there are also feelings about what is going on in the world, feelings that seem to be reports about the condition of our bodies. These are free-floating feelings as well. So yes, we can have free floatings. We're seeing the hornet or the wasp. You feel, uh-oh, here comes a hornet or a wasp. Free-floating feeling. There are free-floating feelings as well, the emotions and moods that qualify our experience of the world and shape our behavior within it. And he notes the actual importance of this. This is what affects are for. They convey which biological things are going well or badly for us. If you're stung, things are going badly. In this respect, affective sensations are different from perceptual ones. And the second thing you'll notice about feelings is that they are always conscious. A feeling of which you are unconscious is not a feeling. The third thing about feelings, felt needs are prioritized over unfelt ones. A selection must be made. This is done on a contextual basis. Priorities are determined by the relative strengths of your needs. There's the size of the air signals in relation to the range of opportunities afforded by your current circumstances. The prioritization of needs, when realized, leads to governing your voluntary behavior. To quote, you decide what to do and what not to do based on the felt consequences of your actions. This conscious choice reveals the deepest biological function of feeling. It guides our behavior in conditions of uncertainty. It enables us to determine whether one course is better or worse. Thus, we feel our way through a problem. So all of this, the need priorities, error signals, context opportunities, all this is going to be, well, has been put into Friston's huge mathematical framework. So there's a feature of the brain's physiology that makes this true. That is, the second thing to notice about feelings is that they are always conscious. For Solms, this is in the brain stem. Positron emission tomography during states of grief, seeking, rage, fear, general forms of affect, show that the highest metabolic activity occurs in the core brainstem and other subcortical regions. Lesion studies, deep brain stimulation, pharmacological manipulation, and functional neuroimaging all point to the same conclusion. The reticulate core of the brainstem generates affect. The reticulate core of the brainstem generates affect. This part of the brain, Solms notes, is the only part we know of that is necessary for arousing consciousness as a whole. It has an equally powerful influence on feeling. Feelings pervade conscious experience, as we've been talking about. Dealing with feelings, which comes from within and regulate our biological needs, appears to be one of the central tasks of consciousness. The neurological sources of affect and consciousness are deeply entangled. So Solms notes, contrary to the classical empiricist view, according to which consciousness flows into the senses, that is, the stimulation, the light from the coffee cup flowing in to the eyes, to the brain regions, etc. It seems the brain does generate its own heat. He asks, what should we call this basic medium, this mysterious mind stuff that seems to will well up within us. He settles on the term arousal. This he relates to various cortical rhythms, the alpha, delta, theta, beta, gamma. For example, the delta, cortical intrinsic, but not associated with consciousness. Or the alpha, stimulated in the cortex by the reticular system in the absence of sensory input. Beta, cortex actively processing external information. Gamma, most aroused, consciousness associated with consciousness. And he states, the cortex becomes conscious only to the extent that it is aroused by the brainstem there. Okay? He proposes this. The shift from pure vegetative state to arousal is controlled by a small, tightly packed set of neurons surrounding the central canal of the midbrain, called the periaqueductal gray, or PAG, where the brain's affective circuitry converges. So lesions there, to that point, send patients into an empty psychoaffective space. They're basically non-responsive. After the cortex and other forebrain structures have performed their cognitive work, after they have submitted their contribution to action, the final decision about what to do next is made at the level of the midbrain, in the form of affective feeling generated by the PAG. Of course, all is not emergency decisions. My coffee stirring takes place in the default seeking, that is just interest, engagement, activity background. He notes current circumstances have to be taken into account. This is affected in the nearby superior colliculi. Here is held a multisensory map, a massively compressed and integrated representation of the exteroceptive, or the external world. This is the objective, that is the objective external state. So he's saying, in this map is the representation of the objective external state, the coffee cup, the world. Here too, a map that controls eye movements. It's intrinsically more stable. Other maps are calibrated relative to it, and why the world is stable, or the eye saccade. The stabilized scene also hints at the fact that we perceive just that, a scene, a constructed perspective of reality, not reality itself. He notes the brain's internal model is the map used to navigate the world, indeed to generate an expected world. Again, we're back to that image being generated by the brain of the world. Why perception, action, and cognition are ever felt at all? They are felt because they are contextualized affect. As if perceptual experience says, I feel like this about that. So the entire origin of the image of the external world, of that coffee cup, is placed upon affect, as though the image is simply contextualized affect. But there's no explanation of the image, just the affect. Solms will spend many more chapters. We've looked at the first 6, which I think are interesting and great. But the next 7 through 12, he spends on explaining the solution to the hard problem, which is really not a solution, not to the origin of the image. However, the model is not going to get any better than this on the origin of the image of the external world, other than its contextualized affect. But this is all integrated into Friston's framework, that predictive processing framework. Here's a brief look just for the idea. It starts with homeostasis, a general principle. Living organisms must occupy a limited range of states. Can't get too cold, can't get too hot. You have to stay within a limited range of temperatures. This brings in entropy. Homeostasis is going against entropy, against the system's occupation of all possible states. And this brings in a notion of, or called the Markov Blanket. Now what's that? Well, it's a system of concentrically layered structures. Here we have an external structure, and then we have a structure within, then another structure, and then another structure. each with an inner core and an outer surface. The states of the red layer are influenced by the outer, the green, and the red influence the turquoise. But the turquoise does not influence the red. And the states of the turquoise are influenced by the inner core, the blue, and influence the red. The external states can only be sensed vicariously, that is, the red-green states, by internal ones as states of the blanket. And we get a partition of 4 states: internal, active, sensory, external. Sensory states feed back the effect of active states on the external states to adjust for their action. In other words, the system is blind. The external world must be inferred. And so yet again, you'll be generating images from memory. How? If there never was a perceptual image. Just interesting. But this brings in the Bayesian inference apparatus. Predictions on the external world with some prior probability. Error comparison. Prediction compared against the actual signal, the actual state of the world. Adjustment of the prediction. Which brings in the Friston free energy principle, which is a big deal in this entire framework. Take a look at it. This impressive equation is entirely in the Bayesian framework for free energy, F for free energy. So despite their impressive mathematics, just look at the terms involved. Here we're dealing with an example of guessing the external world, where T is the temperature in that world, Q of T is our guess about the temperature, and S is the actual environmental state, namely the actual temperature. So F in this formulation is the upper bound on surprise, or F is the surprisal we experience on sampling data given the generative model. And of course, if we're really good at generating guesses, we're not going to get a lot of surprise, which is the whole idea. We don't want surprise, minimize surprise. Now, F is analogized to the physical, in this case, to Helmholtz physical dynamics, like a steam engine for a system. Thus, F is equal to the total amount of energy minus the energy already employed in effective work, if you're a steam engine. Recasting this in the free energy framework, F is equal to the average energy minus entropy, where average energy is again like our guess, the expected probability of an event, and entropy is the actual incidence of an event. So this is how this is analogized to the physical. The mathematical being analogized to something physical. And as I noted, this system always aims to minimize F, free energy, that is surprise. Now add in, formally in your mathematical system, needs, affects, which are driving / weighting the predictions, and you've pretty much got it. All this acts in the framework of a static state to static state comparator, where you're projecting a prediction as an image, again how, check against the environment, get the degree of error, you project a new prediction. Here's a scheme of a comparator, looking at the external world, comparing it against predictions. Take our external world as a cup of coffee. Well, we have to freeze it. We're going to take a snapshot of that event and compare it. So we'll take a snapshot, just as there. We'll stop it for a second and spoon in position, swirl in a certain form. Note, meanwhile, the event is ongoing while we've stopped it to do our comparison. That's something that should be of concern. And we're going to take a prediction, spoons in a new position, and we're going to say, okay, the next position should be as such. And of course, again, you'll only see the projected, or the prediction, the projected static state. You could ask, well, how could this ever work for an actual dynamically changing event? Remember that event's ongoing. And then remember what's worse, the actual structure, multimodal structure, dynamically changing structure, forces, fields, etc. in this event. velocity flow fields, an adiabatic ratio involved, that is the energy of oscillation over the frequency of oscillation, an inertial tensor holding various momenta of the spoon, acoustical invariance, texture gradients, ratios, flows. In other words, contemplate for a moment what it is you're actually attempting to match. Hint, these two events will never match. So just ignoring the Fristonian embedding, in Solms' notion of affect, its brain mechanisms, the activation, arousal of the cortex, the source thereof, I see nothing that is not commensurate with Bergson and his shortcomings on affect and matter and memory. Biophysical dynamics, that which Solms is describing is real action within the body. Now I note again, this video is giving short shrift to time and free will. Beyond the few paragraphs of matter and memory, time and free will and its treatment of pain and feeling. For example, the feeling of lifting successively heavier weight. In Bergson's analysis, this comes from the recruitment of ever more muscles, giving the perception and giving the rise to the perception of ever more weight. So it's a building recruitment of muscles. Solms' framework cannot deal with this. In fact, as you go through time and free will, you find much that Solms' framework cannot deal with. But Solms is trying to explain both affect and the origin of the image of the external world via one mechanism, neural generation. Discussing Chalmers, he simply accepts the formulation. To quote, why should physical processing give rise to a rich inner life at all? But the way the question is posed by Chalmers, physical processing, as physical is currently understood, already presupposes the route to the solution, exactly the route Solms and Friston took. But Bergson essentially redefined the physical, talking the classic metaphysic, where space is an instantly divisible continuum of points and positions, and time is simply a series of instants corresponding to the successive points of a moving object along its trajectory. So he defined it in terms of extensity, undivided and undivided, not the abstract continuum, and duration, an indivisible transformation of the holographic field, not a series of discrete instants. In other words, he defines it in terms of a temporal metaphysic, a break with the classic metaphysic. This allowed conceiving the brain as acting as a reconstructive wave, passing through this always transforming field, specifying a past portion of the field as an image at a scale of time. And yes, we can modify the brain acting as a reconstructive wave when appropriately aroused, because you're going to need the cortical aspect brought into the whole state of the brain as a reconstructive wave, and you're going to need that cortical, that arousal aspect, which brings in how we feel about that, well, very seagull-looking like fly. But Solms and Friston reject this path at the start. To quote, we must go beyond the disciplinary constraints of psychology and physiology. We scientists typically do so by turning not to metaphysics, but to physics. And if your metaphysics is precisely the problem, so Solms and Friston turned to physics. Of course, so did Hameroff, so did McFadden, so did lots of others. But they did not really turn to physics. Yes, they bring in entropy, free energy, homeostasis, but rather they turn to mathematics. They build a mathematical system as a blueprint for the brain. There is a monster difference between creating a mathematical system than using any physical components such that the logical operations are implemented. This is computers, a math system that can be supported with any components so long as the logical operations are carried out. as opposed to describing a concrete system with math as best one can, for precision in building with real components, forces, metals. It's the real physical components that are the key. Example, Steinmetz formulating the laws for building Tesla's AC motor. Very hard to recreate at the time without blowing up, without the precise metals and forces, tolerances, etc. So that book, The Theory and Calculation of Alternating Current Phenomena, was a massive breakthrough. In other words, in the one case, the math is the reality. And then you build a physical system that does the operations, and that's what counts. In fact, the discrete state operations, as opposed to the physical system is the reality. Math at best describes it. There's very little leeway in the physical components of an electric AC motor. You're not going to build it out of toothpicks and rubber bands. Their intent is to engineer consciousness. To quote, if the argument laid out here is correct, then in principle, an artificially conscious self-evidencing system can be engineered. Consciousness can be produced. This will realize the wildest dreams of Helmholtz. Underlying this, consciousness is a part of nature, and it is mathematically tractable. But nature transforms indivisibly. It is not mathematically tractable, only an approximation. And when you're building a real system embedded in the universal field of real systems, real action, approximation is not enough. It is this melodic, indivisible motion where each instant permeates the next, where each instant builds from the preceding. That characterizes the real motion of the field. The body is embedded in this. And this underlies affect. Without this, there is no affect. And none, zero affect is exactly what Friston and Solms will actually have. Now I have the violin playing there because that violin sound is very mellow. And remember what the quality of mellow. We talked about that. The violin is mellow. The room is mellow. The wine is mellow. The kitty is mellow, personality. Mellowness can only build in a melodic, building, indivisible time, not in a series of discrete states. But affect is precisely that, a building in indivisible time. You cannot do this with a pure mathematics. The classic metaphysic and its math cannot support this. It cannot support affect. Its approximation is not enough. It is an abstract, dense continuity of points is not the permeating, each instant permeating the next indivisibly flowing time. And that is the core of affect. And the qualities such as mellow. So the mathematical mechanism bleeds through in Solms. To quote, current needs, residual prediction errors quantified as free energy, converging on the PAG are ranked. This triggers conditioned action programs, which unfold in an expected context over a deep hierarchy of predictions. The actions generated are voluntary, which means they are subject to here and now choices rather than pre-established algorithms. But an algorithmic system, algorithmic mathematical system, is precisely what is being described. An algorithm will make these choices. Or, what will happen to my free energy if I do that? The answer to this question will always determine what the system does next over a suitable time period. This is the causal mechanism behind all voluntary behavior. Someone asks the causal mechanism behind free will, behind voluntary behavior? Yeah, surely, rather a Zen koan. They slip into this language because they're actually building truly a causally determined system. Mathematical state to mathematical state. Or to quote, the free energy principle dictates that all the quantities that can change, that is, that are part of the system, will change to minimize free energy. In fact, This is more than a pithy formulation. It is a law. It is a law. So choice here sounds pretty illusory. We're talking a deterministic mathematical system. Well, physics with its mathematics is not the safe space that Solms believes, or Friston. We've seen a certain U-boat Capitan a couple times. Here, Dr. Schrödinger. His first torpedo, the wave equation, has big problems. It has no ontology. His cat embodied this. Torpedo 2, current physical law cannot embrace the phenomenon of life. And that's surely what we're dealing with here. So in a coming video with respect to Solms and Friston, I think, we'll look at his third torpedo. The quantum jumps of quantum mechanics have no actual reality. That is, discontinuous jumps are a mathematical reality, not a physical reality. Here, Schrödinger will join Bergson. We'll see from Erwin Schrödinger's point of view why the mathematical framework of physics / QM is not sufficient to the actual physical universe, and certainly then not to mind and brain. So, we'll see next time. Till then, signing off.